encryption. These algorithms are known to each other. Compression method is known to each other, and the two random numbers for key generation. Remember, after phase 1, key generation is not completed. It is just the information that which algorithms for message authentication, key exchange, and encryption is going to be used, which SSL version is going to be used, and the random number which are required for the sequence calculation of the pre-master secret that is shared. Okay, now comes phase 2. Now this is very interesting phase. Now server will say that I am authenticated server. Remember, this server says, okay, this initiation comes from the server. So if client wants authenticated server, then server has to first authenticate that I am the correct server. It is not the situation that some other machine, some other entity may pretend to the client that I am the server. This is to prevent that type of attack, right? So before key material is generated, server will authenticate itself with this step where it will send a certificate, right? Certificate, you know the certificate, right? Like if you send a certificate to somebody, then certificate is an authentication, right? Certificate is authentication. If you say that I have BTech in computer engineering from DDU, then it is an authenticated, right? So you are authenticated. So this certificate is also like that. The concept is same. So there is a third party certificate authority. CA, I think that concept is all clear to all of you. So between client and server, there is third party certificate authority, which will generate certificate to the server. Now server will send that certificate to the client. Client, when it receives that certificate, it knows that it is given by some third party. Because it is given by certification authority, then it is confirmed that this is actually authenticated server, right? So here it may say send a chain of certificate. Then second thing, what it will send, once the authentication is done, server will say that this is my key. So server will send its own public key. Remember, any other machine which may pretending to be the server may send public key. But before public key, we are sending certificate. So it ensures that server is authenticated. Hence, this public key is valid public key, right? So in the second step, it sends server public key. And the third is certificate request. This is an optional step from the server. Server may request client that in the next phase, phase 3, I want certificate from you. That means I am authenticating myself, but now you also authenticate yourself. I have a valid degree, but you also give me the valid degree. Degree in the context of certificate for your better understanding in simple terms. Okay, on both sides, they have to give some certificate, right? So list of acceptable certificate, which is given, it is given as a request to the client. The server will say that give me your certificate. Okay. Then fourth step, server says, hello, server, hello, done. That means this phase is over. Okay. So it will not send. So remember, this hello is over here, which started here, right? So first client hello, server hello. In second phase, server sent this much of information, including a request from the client to the client, and then it will say that, okay, my hello is done. Okay, is it understood, all of you? So the third phase is, so after the second phase, server is authenticated to the client, and the client knows the public key of the server if required. Okay, client knows the public key of the server. Now, after sending this step, client has the server's public key, but server doesn't have client's public key. So client has to send this public key, but before sending this public key, it has to authenticate itself. That is the third phase. Okay, that is the third phase. So in the third phase, it sends a chain of certificate. Client says that I have received your degree, or I mean, sorry, certificate. We use the term in the context of always degree. That is why this degree term is coming up. But it is simple some certificate. Okay. So certificate goes from client to the server. Okay. Certificate goes from client to the server, right? There are so it may also happen that you go to some place. So suppose you attend some workshop or some seminar, so you get some certificate, right? So that is the authentication, that this is the certificate which is received. So a client will send a certificate to the server, and then that server receives that certificate. Then it will verify from that certificate authority that this certificate is really correct certificate or not. So if the issuing authority is not certifying that certificate is not valid, so client is not authenticated, right? So if there is any certificate which is not issued by the certificate authority, or that certificate is expired, then this certificate, even if it reaches to the server will not authenticate the client, and then this phase will not completed, right? So in order to complete this phase, this certificate should go from client to the server. In the next step, client will send its own public key. If the certificate is authenticated, then the public key is sent. And once the public key is sent, then the third step, which is the very important step, that is hash code to prove the certificate. This is the hash code, certificate verified. Hash code is sent. Okay, similar to the hash algorithm which are used, SHA and other algorithm, this hash key is calculated and it is sent to the verification purpose, right? So on the server side, if this certificate verify is authenticated, then the phase 3 is over. So after phase 3, the client is authenticated for the server. Both the client and server know pre-master secret. Now what happened? Client and server both have sent in phase 1, both have sent client random number, server random number. So both knows client random number, server random number. Now phase 2, public key is known. Server's public key is known to client, and server has its own private key and public key combination. Client sends its public key and client has its own public key, private key, right? So on both sides, both have exchanged their public key, private key, random number, and client random number, server random number. So that is why, so here what I have shown to you in this diagram, whatever is required, this is pre-master secret, right? So after phase 3, almost everything is exchanged, and this pre-master secret is going to be created at the end of phase 4, which is the finalization phase. So in the phase 4 of the handshake protocol, client sends change cipher specification. This is another separate protocol. So it will send the value for that protocol, and it will say that I have finished by sending hash of MD5 hash plus SHA hash, right? So it will send that. Server will also send the value of change cipher specification value with MD5 hash plus SHA hash. Okay, so both of this is finalizing and sending the finish. Final hash value is exchange. So at the end of phase 4, client and server are ready to exchange data. Okay, so many other things are there in detailing, but I am not discussing all the detailing. that I leave it to you. Now, the important part is that in the beginning, I have shown you the different services, right? How these 5 services, right? Fragmentation, compression, message integrity, confidentiality, and framing. So I will now show you the diagram on sender and receiver side, how these services are obtained. So you can see in this diagram, payload from the upper layer protocol, that is application layer, has data to send. With the help of SSL, we want to send data. So the first thing what it will happen is fragment 2 raised to 14 byte. So this payload is converted into fragments of 2 raised to 14 byte, and each fragment goes through this process. So fragment is compressed with some specific compression algorithm, and then the hash value is calculated. Hash is something like a CRC, right? Checksum, right? So with the help of this hash, we create message authentication code, which is like checksum. So compressed data is having a hash MAC, which together is encrypted. So here, write MAC secret. We remember we generated 6 secrets: 3 read, 3 write, 1 for authentication, 1 for encryption, and 1 for initialization vector. So here for compression, here for cipher encryption, and then this encryption fragment, encrypted fragment, becomes your SSL payload, for which this RPH header is added, and this header contains this information. Okay, this header contains protocol field, version number, length, and then the compressed fragment, and then message authentication code, which is like a checksum. Okay, all encrypted. Okay, so this is created. This is created on a sender side, client side. Now server or the receiver will receive this encrypted payload. Okay, encrypted payload with the header. So on the receiver side, it will receive this, it will remove this, check this header. If it is proper, then it will give the encrypted fragment. It will appropriately use read method, read secret, because write read pair is there. So if there is one write cipher secret, on the other side there is a read secret. So with the help of that read secret, the encryption is the encrypted fragment is decrypted. Then that decrypted fragment is checked. Its message authentication code is valid. If that is recomputed with the help of read MAC secret, which is again available on the other side. And if this is valid, then the compressed data is taken for decompression. The decompression algorithm is applied, and then the fragment is created, and all these fragments are collected at the application layer. Okay, is this process clear? Processing done by the record protocol. This is actually a record protocol. I discussed the different protocols are available, right? So here I have discussed that there are different protocols. So this is the record protocol. Can you see this record protocol? Right. So this is the process of the record protocol I have discussed with you. Okay. So all 4 protocols and this is the calculation of the MAC, the message authentication code. Okay. You can see that there is a sequence number, compressed type, length, compressed fragment, pad 1, MAC secret, and then SHA and MD5 is applied, hash is created, again pad and MAC write secret is applied, again SHA and MD5 is applied, and then the final MAC is created. Okay. So I hope that you have enjoyed studying this network security subject. This is chapter number 17. So I have discussed the important aspects of SSL. Okay. So I wish you all the best for your 3rd sessional exam and upcoming all examinations. Once again, wish you all the best. Now you can have your lunch.